I want you to picture this. It's the single best moment of the week. Friday afternoon.
Oh, yeah.
Let's say, 4:57 p.m. You are technically still at work, but your brain has already clocked out.
The checking out phase. Absolutely.
Exactly. Weekend plans are locked. Dinner is decided. Maybe a beer is cooling in the fridge. You are 3 minutes from freedom, and then you hear it.
The Slack notification.
That specific ping.
The ping of doom. Always right at the finish line.
It is, and it's your manager. Hey, just a quick fix before you head out. The user table in staging has some duplicate emails. Can you clean it up?
And that's the trap.
Mm-hmm.
Because you're a good engineer. You want to be helpful. And, you really want to leave on time. So you think, sure, easy.
5-minute job.
Yeah.
You don't want to be the one who says, wait till Monday for something so small.
Right.
So you open up your terminal. You've got 2 tabs, side by side. Left tab is staging. Right tab, production.
I can feel my heart rate going up just hearing this setup. It's the classic blunder.
So you type the command, drop table users. You hit enter. And usually the database responds instantly. Query, okay, whatever. But this time,
Nothing.
just a blinking cursor for 8 seconds. That's a long time for a database.
That latency is terrifying. That's when the universe just seems to suspend itself.
And then the silence is broken.
Yeah.
Not by the terminal, by Slack absolutely exploding.
Oh, no.
Sales is screaming, I can't close deals. Support is yelling, customers are locked out. And then the engineering channel lights up, who the fuck broke prod?
Because you weren't in the staging tab.
You were in the production tab. And you didn't just drop a table. You actually ran drop database production.
Oh, wait.
In less than a second. 47,000 customer records, 3 years of transaction history, and, the entire business. Gone.
That is not just a mistake. That's an extinction event. We're not talking about a button being the wrong color. We're talking about the kind of error that ends companies. And, 99 times out of 100, it ends a career.
But, and this is the massive but we are unpacking today, this story doesn't end with a cardboard box and a security escort. Today, we're doing a deep dive into the $47 lifeboat.
Mm-hmm.
We are unpacking a source that details a real-world catastrophe, a massive human error, and the secret, kind of unauthorized system that brought a dead company back to life.
And what's so fascinating here is that this isn't just a story about, a clumsy engineer. It's a masterclass in disaster recovery.
It really is.
We're going to look at this unwritten algorithm for survival, how a rogue backup system that costs less than $50 a month saved millions, and the specific technical steps you need so that when human errors strike,
And it will.
you have a safety net ready to go.
So let's go back to that moment. It's 5:02 p.m. The database is gone. The source describes this visceral physical reaction, a metallic taste in the mouth.
That's adrenaline, pure and simple.
Yeah.
The physiological response to just terror. The source actually breaks down the timeline of the brain in disaster mode, which I found really compelling. It says the first 8 seconds are just silence. Your brain actually refuses to process the input.
It's like a system freeze in your own head.
Exactly. Then you get denial. Did I just? No, I couldn't have. Then bargaining. Maybe that was the staging server, surely. And then, section 7 and 8. Absolute crushing realization.
The narrator admits something pretty raw here. They had this fleeting thought of just running away.
Like literally running.
Literally. Closing the laptop, deleting Slack, changing their name, and moving to another country. Just disappearing.
Which, honestly,
Yeah.
that's a very human reaction. The fight or flight response kicks in hard, and flight looks really good when you've just deleted the company's entire existence.
Right. But they chose to stay. And this brings us to the first crucial lesson from the source, the stop the bleeding strategy. In that first 60 seconds, panic is the enemy. You have to switch from, oh my God, to what now? And their first move wasn't even technical, it was communication.
That's so important.
Minute 1, they post in the incidents channel, production database deleted by accident, working on recovery, ETA unknown.
That takes an immense amount of guts.
So,
Most people want to hide the body. They want to fix it before anyone notices.
right.
But you cannot fix a missing database in secret. Total transparency here is vital because it buys you air cover. If you tell people, I broke it, I'm fixing it, they stop asking what's wrong and hopefully let you work.
So, minute 2, the technical part. They ran sudo systemd stop PostgreSQL. Now, I want to unpack this because it seems counterintuitive. If the database is gone, why stop the service?
It's about preserving the crime scene. Think about a hard drive. When you delete something, you're not actually scrubbing the disk clean. You're just telling the computer, hey, this space is now available to be written over.
Okay, so the data might technically still be ghosting around on the disk somewhere?
Potentially. But more importantly, your application doesn't know the database is dead yet. It might still be trying to write new data. And if those write requests hit a corrupted system, you could overwrite the very disk space where your old data used to be. You have to kill the process to stop the application from making the disaster permanent.
Okay, so the bleeding has stopped. Now it's minute 3, the pivot to backups. And this is where the story gets really complicated because officially, there were no good backups.
That's right. The classic startup dilemma. The manager had rejected a comprehensive backup plan. You hear the usual arguments. We're too small. It's too expensive. We'll do it later.
Famous last words.
It's technical debt, but in this case, it was an existential risk.
But the engineer had gone rogue. 3 weeks earlier, they looked at that rejection and just said, no, that's dangerous. So they built a shadow system.
A secret weapon. An unauthorized infrastructure.
Yeah.
And we really need to unpack this specific setup because this is what saved them. It wasn't just, a simple copy-paste. It was a 3-layer system.
Let's break those layers down. I think a lot of people just assume backing up means saving a file somewhere. Layer 1 seems pretty standard automated PostgreSQL dumps.
Yeah, that's the baseline. They had a cron job, just a scheduled task running every 6 hours. It takes a snapshot of the database, zips it up, and leaves it on the server.
Which is better than nothing, but if the server itself melts down, the backups melt with it.
Exactly. That's why Layer 2 is so essential. Oxide storage, they had a script syncing those files to AWS S3, specifically the Glacier storage class.
Glacier's the super cheap, slow retrieval one.
Correct. It's for data you hope you never, ever have to touch. Costs pennies. It ensures that even if the whole data center explodes, your data exists somewhere else.
But Layer 3, this is what the source calls the game changer. And I want to get technical for a minute because this is the real aha moment. Point-in-time recovery, or PITR.
Yes.
Why does this matter so much more than just having that snapshot file?
This is the critical piece most people miss. Look, imagine your backup is from 4:00 p.m. You delete the database at 5:00 p.m. If you just restore that backup, what happens to everything that occurred between 4 and 5?
It's just gone. Every new user, every order, every comment. In a high-volume business, that 1 hour could be a disaster.
Exactly. That's your recovery point objective, or RPO. A snapshot has a bad RPO because it leaves these huge gaps. PITR solves this using something called write-ahead logging.
Write-ahead logging, I've heard the term. Is it like a diary for the database?
Think of it like a flight recorder, a black box. Before a database actually writes a piece of data to the hard drive like add user John Doe, it first writes that intent to a log file. That's a write-ahead part. It writes the plan before it executes it.
So it's recording the action before it commits the result.
Precisely. It's a continuous sequential stream of every single transaction. Insert, update, delete. By archiving these logs continuously, pushing them to the cloud every few seconds, you're not just saving static snapshots, you're saving the entire history of actions.
Which means you can replay the tape.
You can replay the tape, and more importantly, you can stop the tape whenever you want. You can say, replay everything up until 4.59 and 59 seconds, just before the disaster.
And this entire rogue setup, the storage, the snapshots, the logs, it all cost a grand total of $47 a month.
$47. Less than a gym membership to save an entire company.
So they have the system, now they have to use it. It's 5:03 p.m. The narrator checked the backup list. The latest snapshot is from 4:0 p.m.
Which is a problem. The deletion happened at 5:00 p.m. If they only had layers 1 and 2, they'd be looking at a full hour of data loss. The source says, could have been worse, but let's be real, losing the last hour of business on a Friday is catastrophic.
So the recovery begins. It's 5:07 p.m. They create a new empty database. They start unzipping that 4:0 p.m. backup. And this part isn't instant, right?
No, this is the slow part. You have to physically write gigabytes of data back onto the disk. By 5:00 p.m., the database is back online, but it's an hour old. It's in the state it was at 4 p.m.
And this is where the magic of those wall logs comes in, the time travel feature.
Yes. This is where the engineer earns their paycheck. They go into the Postgres config settings, they set a parameter called recovery target time, and they set it to literally seconds before the drop database command was run.
And then they just hit go.
They restart the PostgreSQL service. The database wakes up, sees it's currently at 4:00 p.m., but it also sees this pile of log files that go up to 5:0 p.m., and it just starts rapidly replaying them. It re-executes every single transaction that happened in that hour.
It's like fast-forwarding a movie and hitting pause right before the car crash.
That is the perfect analogy. It just races through those transactions. By 5:32 p.m., the database had replayed everything, every record, every transaction. Systems were back online by 5:50 p.m.
So total downtime, 47 minutes, data lost, 0 bytes.
It's a miracle of engineering, from business is dead to sorry for the brief interruption in less than 1 hour.
But of course, the technology is only half the story. The engineers still deleted the production database. They still had to face the music.
The Monday morning reckoning. This scene in the source is, well, it's cinematic. It's 9:00 a.m. conference room. You've got the CEO, the CTO, the VP of engineering, and HR.
And the narrator is just sweating bullets.
Well, yeah.
They walk in knowing they made the mistake. And to their credit, they own it immediately. The narrator admits, I rushed, I used the wrong tab. But then they pivot.
This is the key moment. They don't just apologize. They explain the recovery. They reveal the secret backup system. And the CTO challenges them, right? The CTO says something like, wait, you built backups without approval? I told you not to spend time on that.
That is high stakes. Standing in front of the execs and admitting you disobeyed a direct order. That's usually grounds for termination right there.
But the results speak for themselves. And then the pivotal exchange happens. The CEO, who is, just looking at the bottom line, asks, how much did this system cost?
The narrator says $47 a month. And the CEO turns to the CTO, the one who rejected it, and asks the question that probably haunted that CTO for a long time.
Yeah.
And you said no to $47 a month?
Oof, that had to hurt. But the CEO's realization is immediate. He says, $47 a month sounds cheap now, because the alternative was losing the entire business.
So what was the verdict?
Surprisingly, no, they weren't fired. They were put on database duty for 6 months, which is a bit of a punishment,
Sure.
but it's also a responsibility. The CEO basically said, you broke it, you fixed it, now make sure it never ever happens again.
Which leads us to the lessons learned part of the source. Because they didn't just go back to business as usual, they redesigned how the company handles data to account for the fact that humans are, well, human.
This is the core philosophy shift, designing for human error. We always try to train people not to make mistakes, but that fails. People get tired, they get distracted. You have to build systems that assume mistakes will happen.
So what's the first major lesson?
Untested backups do not exist.
I love that phrase, trust but verify. So many companies have these scripts that run, they create a file, and everyone just assumes they're safe.
Right. But when disaster strikes, the file is corrupted, or it's empty, or the decryption key is lost. If you haven't actually tried to restore the data, you don't have a backup. You have a hope.
So what do?
They set up an automated script that every week restores the production backup to a test environment. If it boots up, the backup is good. If it fails, alerts start firing.
Then there are the visual safety nets. The source mentions color-coding terminals.
It's so simple, cheap, and effective. They set it up so if you're connected to a production server, your terminal background is bright red. Staging is green.
It taps into that reptilian part of your brain. Red means danger.
Exactly. It stops you from autopiloting into the wrong window, and they added the read aloud rule.
This one sounds a little silly, but I actually tried it after reading this, and it works.
It does. Before you type a destructive command like drop or delete, you have to read it out loud and wait 5 seconds. It forces cognitive engagement.
It breaks the muscle memory.
It breaks the loop and gives you a chance to catch that, wait, drop database moment.
And of course, the Friday lockdown.
The new rule: no production changes after 3:00 p.m. on Fridays. If it's urgent at 5:00 p.m. on a Friday, it waits until 9:00 a.m. Monday. Because tired brains make mistakes, and Friday afternoon brains are the tiredest of all.
It really highlights how many so-called tech problems are actually process problems.
Absolutely. And the source makes a fascinating comparison of outcomes to drive this home. They look at the alternate realities of what could have happened.
Right, let's look at those. Scenario 1, no backups at all.
Company dies. 100% data loss. Lawsuits. The engineer is definitely fired, probably sued. Total ruin.
Scenario 2, just the weekly backups the manager originally wanted.
You lose 6 days of data. Revenue loss is estimated at over $200,000. Massive reputation damage. You survive, but you're limping. You probably lose half your customers.
And scenario 3, the actual result, the $47 lifeboat.
Minimal impact. A $3,000 revenue loss from the downtime. Job saved. Company saved.
The source uses a great analogy for this. It says, we'll set up backups when we grow. It's like saying, we'll buy fire extinguishers after the building burns down.
It captures the absurdity perfectly. We see things like backups as a sunk cost, Why am I paying for this if I'm not using it? But really, it's the cost of survival.
You don't buy the fire extinguisher because you plan to have a fire.
You buy it because fires happen whether you plan for them or not.
And the final provocation from the source is really about the inevitability of error. They mention that even giants like GitLab and AWS have had massive outages because of a typo or a script error.
It brings us back to that question of paranoia versus preparation. The narrator says, "Some people call me paranoid. I call it prepared." The goal isn't to be a perfect engineer who never types the wrong command. That person doesn't exist. The goal is to build a system that can survive you at your worst.
That is a powerful way to frame it. A system that can survive you at your worst. Because we are all going to have a worst day eventually.
Precisely. We all have days where we're tired or rushed or distracted. Your systems need to be smarter than your worst moment.
So if there is one thing you take away from this deep dive, let it be this. Go check your backups. Not just that the file exists, but that you can actually bring it back to life. Do a drill.
Because you never know when it's going to be 4:57 p.m. on a Friday.
And you definitely don't want to be the one staring at an empty terminal wondering if your resume is up to date.
Stay safe out there.